Hi, in this video I'm gonna go over a few examples of solving trig equations using certain identities. Okay, so on the right hand side of the screen you see a bunch of formulas, right? So we have tangent theta is equal to sine theta over cos theta, which we learned that a long time ago. And we also learned the second one, sine theta squared plus cosine theta squared is equal to 1. We learned those two long time ago, right? So what about the formulas at the bottom? Okay, so is all of this, they are called the double angle identity. Okay, why do we call that? Because you can see that all of the angles, there's always 2 times theta, right? So we call that double angle. Okay, so you have this sine 2 theta, cosine 2 theta, and tangent 2 theta. We do not have to remember every single one of them. However, if you do remember them, you will save a lot of time because you don't have to flip through the formula booklet looking for the formulas. And if you do that many times, eventually you will be wasting a lot of time. So I do recommend you guys to remember them. Okay, now anyways, I'm gonna go over 2 examples and I'll show you guys how to make use of all these identities, all these formulas to help us to find what we want. Okay, so on the left the question says, given that sine of x is just an angle, sine x is equal to 3 over 4, and the value of x must be between 0 to 90. The value of x must be between 0 to 90, and they want us to find the exact values of a, b, c, d. Now to begin with, let me ask you, if you have your unit circle, is there an angle x that has a sine value, which means that has a y coordinate of 3 over 4? Look at your unit circle. Is there any angle that will give you that sine value? We don't know, right? Because maybe there is, but it's not on the unit circle, right? So in the previous sections, we were able to use a unit circle to find the angles that will give us whatever sine, cosine, or tangent values, right? So now we're talking about angles that are sort of maybe, for example, something like maybe 27 degrees, or maybe something like 47.5 degrees. You know, numbers that are not 30, 45, 60, 90, not the special angles, right? So this is when all of these identities, all of these formulas are going to help a lot. Okay? Now, let's try to actually solve this. Keep in mind, we have this restriction, this my domain, right? My domain has to be between 0 to 90. In other words, my x is going to be somewhere there. This is 0, this is 90 degrees. So my x is in the first quadrant. Just keep that in mind. Okay? Now let's look at part A. Part A, they want us to find cosine of x. So cosine of the angle. What's the value of cosine x? Okay. So now I'm gonna look at the formulas that I can use. Tangent theta equals sine over cos theta. Well, I don't have this. That's a question mark. So, and my cosine theta is something we have to find, which means that's also a question mark. The only thing that I know right now is this, right? So I have 2 question marks here. That's not good. I'm not going to use that. Okay, let's look at the second one. I have sine value. I have a sine value, and sine square theta, I can do that. I can find that. Just square whatever my sine value is. That I don't know, right? And I have a 1. So in this case, there is only one unknown, which is my cosine square theta, or cosine theta squared. So that's the one I'm going to go for, because there's only one unknown, right? So I'm going to say sine square x plus cosine square x is equal to 1. Sine square x means sine x, the whole thing squared, plus cosine x, the whole thing squared, is equal to 1. Now what's sine x? Sine x is equal to 3 over 4. So this is 3 over 4 squared plus cosine x squared equal to 1. So cosine x is equal to, squared, there will be 1 minus 9 over 16. That will be 7 over 16. Okay? And let me bring this up. So cosine x, I'm going to square root both sides. I'll get 7 over 16. Now be careful here, because we introduced the square root, right? So I'm going to add another line here. I introduced the square root to cancel out the squared. I introduced the square root to cancel out the squared. So we must be careful. Please be careful. This will be plus minus, right? Plus minus. In other words, my cosine x is equal to plus minus root 7 over 4. Okay. Now, so my cosine x is equal to root 7 over 4 or negative root 7 over 4. Right? However, I cannot choose the negative value. Why? This is not a solution. Why though? Why is that not a solution? If you think about it, so this angle, whatever angle that is, even though I have no idea what that angle is, but it's fine, because this angle x over here is the same as the x of my sine value, right? It's the same angle. And just now we already, before we started applying any of these formulas, we sketched this diagram right there, right? And we found out that my angle is actually in quadrant 1. My angle is in quadrant 1. If my angle is in quadrant 1, what is my cosine value going to be? Can it be negative? Quadrant 1 is over here. So my cosine value of that angle cannot be negative. And that's the reason why I cancel it out. Okay? So the only cosine x, the only cosine value of the angle is root 7 over 4. All right? I hope you guys understood this part where I'm canceling out the negative part. That is very, very, very important, okay? Because that's what the concept is all about. All right, let's look at part B. For part B, I have this sine 2x. So what I'm going to do is I'm just going to, let's see. Sine 2x, I can use this. I can use my double angle identities. So my sine 2 theta is equal to 2 sine theta cosine theta, right? So my part B, sine 2x is equal to 2 sine x cosine x. Cosine x. And from my sine x is just 2 times 3 over 4 times cosine x was equal to how much? Root 7 over 4. Root 7 over 4. And that gives us 3 root 7 over 8. Okay? So my sine 2x is equal to that. Now let's see part C. They want us to find cosine 2x. So let's refer back to our formulas. Cosine 2x is here. This is my part C. Let me change that star should be part B. Right? Part C is equal to, so for cosine of 2 theta, we have a bunch of choices. And I'm just going to use, I will use the first one. All right, cosine squared theta minus sine squared theta. So this is equal to cosine square 2x, cosine square, sorry, if you be careful with this, you see that this is 2 theta, and I have theta, right? So if I apply that formula to this question, I'll get cosine square x minus sine square x. Sine square x is equal to 3 over 4 squared. Cosine square x will be root 7 over 4 squared. So this is root 7 over 4 squared. And that will give us 7 over 16 minus 9 over 16. So I have, my final answer will be, that's 8. 8 over 16. Oh wait, what am I doing? Sorry. This is negative 2 over 16, which is negative 1/8. Negative 1/8. Okay? All right. Now, what about part D? Part D, tangent 2x. So again, I'm going to refer back to my formulas. Tangent 2x is equal to 2 times tangent theta. Tangent 2 theta is equal to 2 times tangent theta over 1 minus tangent theta squared. Tangent 2x will be tangent of x over 1 minus tangent x squared, right? Oh, I'm missing a 2 there. Sorry about that. There's a 2 there. Okay, now I don't have my value for 10x, so I can find my 10x. In this case, 10x is equal to sine x over cos x, right? So sine x is equal to, my sine x is 3 over 4 over, my cos x is root 7 over 4. So I can multiply 4 to both my numerator and denominator. I'll get 3 over root 7. Rationalize my denominator. I'll get 3 root 7 over 7. So that's my tangent x. Okay? So now I can put this in. But my tangent 2x becomes 2 multiplied by 3 root 7 over 7. The whole thing divided by 1 minus 3 root 7 over 7 squared. And that will give us 6 root 7 over 7. The whole thing over 1 minus, what's that? That's 49. 9, 7, that's 63. Oh, this is so ugly. And I'm going to put that in my calculator, so I'll be back. That will be negative 3 root 7. Okay? This is actually the long way. This is not the fastest way. Think about what is the fastest way. So I'm going to use a different color. I'm going to use green. The fastest way for this will be, wouldn't tangent 2x equal to sine 2x over cosine 2x? Isn't this true? Right? So for part B, we already found this. So that would go to the top. So I have 3 root 7 over 8. And for part C, I found that my cosine 2x is equal to negative 1/8. This would be negative 1 over 8. So if I multiply 8 to both my numerator and denominator, that's it. My answer is done. So I'll get negative 3 root 7. So much faster than applying the formula, right? So don't always just think about applying the formula. Look at what you have. Look at what you have done in the previous parts and see how you can take advantage of them. And I'll see you guys in the next video, okay? Please feel free to rewatch this video and bring questions to class. All right, bye-bye.